Hey folks, welcome out there. Woo, I like that going up. And how about it? We're so glad you tuned in this afternoon with us. I am Ernie Roberts, and I'm your host for this afternoon's session of Mathline. My sidekick Gary Petco's gone today, but we're going to probably echo some of his comments and such as we go. And he's not here to defend himself, right? However, what we would like for you to do is make your comments, actually give us some problems to work with, all right? And that number to call, 844-686-2378. We'd love to hear from you. You make the show rock when you call in. And speaking of which, incentive to call in, you get to talk to Talea, who is our Fulton High School Key Club member, on the phones today. Let's take a picture there, all right? And as it looks like someone's already getting to her, you give us some calls, all right, folks, and we will take good care of you. From Fulton High School Key Club, we thank you. Key Club members from Bearden and also from Fulton have come in and helped out. If you've got a Key Club that would like to come and do phone answering for us, that'd be great. If you have any kind of a high school service club or even a middle school service club or an organization would like to come in, we'd love to have you. But enough of that. We want to hear from you. Again, that number, 844-686-2378. We definitely love it when you call in because it makes the show rock. And speaking of rocking, Facebook's rocking today because there are a lot of people making some comments, sharing all sorts of things with our problem of the day. So let's see what it's all about. A school club sells 150 pounds of fruit to raise money in 5 and 10 pound bags only. All right, that's a restriction right there. It can only be in 5 pound or 10 pound bag. And how many different ways can those bags of fruit be sold? So in other words, we're basically going to figure out how many 5 pound and 10 pound bags are possible. Now, one of the comments that was made on Facebook, and it's really very true, is, well, there are a lot of answers to this. Absolutely. That's why we're asking, how many different ways can the bags of fruit be sold? And another question was, well, could it be all in 10 pound bags or could it all be in 5 pound bags? That's an option. That's an option to work here, all right? So in answer to those, there are many other ways. So here's what we're going to do. We're going to try to explore this and see how quickly we can get through this thing. And first of all, we need some sort of a relationship. So we're going to call the X, we're going to let X equal the number of 5 pound bags. And we're going to let Y equal the number of 10 pound bags. And let's see what we got going here. You say, well, that makes sense. Yeah. So it's not an X plus Y, it's actually what? It's going to be 5X because that's what the value for each of these bags is. And it's going to be added to 10Y, which eventually means we're going to have 150 pounds of fruit. There's the connection, all right? So we started with that 150, right there it is. We take 5 times our X because that's, hey, 5 pounds bags. We're going to have 5 pounds in each bag, right? And we do the same thing with the 10Y because we're going to have 10 pounds of fruit in each of those bags. Ooh, that's heavy. We start thinking about it. So you say, Ernie, what's it going to do for us? Because there's not another clue. So we aren't going to get an exact number as we did on our systems question yesterday on the problem of the day. We were able to get that test question to work out exactly right. So what we're looking at is how many different ways? What are the options? There are a lot. So hang on for just a few minutes, all right? We're going to play through this thing. First of all, to help us out, let's do this. Let us go to slope-intercept form. He says, slope-intercept, what's a line here? What's going on? Let's get Y by itself, all right? I think it's going to work and settle us a little bit easier. Hey, we could also do the X by itself. It's 6 of one, half dozen the other, or in this case, 5 of one, 10 of the other. But we're going to simply get rid of the 5X, and we're going to play this thing out to say, how about it? 10Y equals a negative 5X plus our 150. And you say, Ernie, what's that about? That means we're going to get that divided by 10, and we're going to divide by 10, go through here, and look what's happening here. We're getting Y equal a negative 1/2 X plus 15. Now, remember, Y is what? Y is the number of 10 pound bags, right? So let's suppose we don't have any 5 pounds, 0, all right? We put a 0 in there and we see what happens. We're going to write it up here because I'm going to need a lot of room here. We're going to have 0 and 15. If I put a 0 in there, see what just happened? Oh my goodness. Now, someone's going to ask, well, what if you put a 1 in there? If I put a 1 in there, I'm going to have like, looks like goodness, what? I'm going to have a negative half plus. That's not going to fly here because we either have a pound bag of it, 10-pound bag, or we don't, all right? So we can't use 1 as our value, but we certainly can put a 2 in there because what happens here? When we put a 2 in there, we get a negative 1, and we add 15 to that. We're up to 14. Now you say, Ernie, I don't know if I buy that. Well, let's see if you can. 2 times 5 is 10. 14 times 10 is 140. Add 10 and 140. Guess what? You've got 150. This is really a cool way to figure out the answer to this problem. So we figured out 1 didn't work. I guarantee you 3 isn't either. Odd numbers aren't going to work in this case. So already some of you are starting to think, aha, I think I see what's going on. So let's run 4. What is 4 going to do for us? We're going to put a 4 in there, and I bet you we're going to come down to 13. Want to check? Sure you do. 4 times 5, 20. 13 times 10, 130. Woo, put those together. 150. We're on a roll. So again, remember, X is our what? 5-pound bags. Y is the 10-pound bags. Remember that if we multiply by 5, multiply this by 10, we add up to 150. So again, you got the idea. You're going to skip 5. Everybody did that, right? So now we're going to 6. And it looks like we're going to drop down to 12. And again, you can check that through, and you're going like, well, wow, Ernie, how well is this going to work out? Well, let's see. Let's keep it going here. How about it? We're going to go 8. We're going to be at 11. Everybody good on that? It's 40 plus 110. How about the 9? This is what our Facebook folks were finding out, the nice combinations here. There is a pattern, definitely is. So we've now gone through, do we want a 10? We don't want a 9 there. We want 10, don't we? All right, so let's see what just happened. We just broke even, didn't we? 10 and 10. So, see, you got to catch up there. That should be 10. I'll put it right down here. We'll put it 10 and 10. Because once again, we can't have an odd number popping in there. So there's 1, 2, 3, 4, 5, already up to 6 options. There's plenty more, aren't there? So let's just play it out. Here, let's count them up. We'd have 12. How about 9? We'd have 14. How about 8? So see, we keep dropping down. As we go up on one side, we're dropping down on the other. 16. 7. 18. 6. 20. We're almost there, my friends. 5. Does that make sense? 20 times 5 plus 5 times 10, still at 150. Is that not amazing? And let's go one more round here because we have now put up 1, 2, 3, 6, and 5 more. Hold your breath. We're about done, all right? Let's go to it. How about it? 22. We'll go 24, 26, 28, and yes, we're going to come back to 30. I'm counting 16 options. You said, well, Ernie, what's going to happen at 30? We're going to be at 0, right? Because basically it looks like we're having a blast off here. All right, so put a 4, a 3, a 2, a 1, and my friends, the answer is, as many of you had on Facebook, 16. Great problem, wide open, a lot of things going on there, but remember the whole idea, multiplying it through, we're going to add up to 150. And speaking of things that are good, because I like that problem and I love the response we had on Facebook, let's go to a caller who is welcoming us today. I'm welcoming them, and you know what? We're glad to have you with us today. Welcome to Mathline. And who am I talking with today?
Alyssa.
Alyssa, how are you doing today?
Good.
And listen, just to remind everybody, where are you calling from?
Spencer.
Spencer, all right, and we're glad to have you with us. What kind of problem you got for me today?
I don't really know.
Oh, well, we'll go for something. How about it? See what you got.
It says if 1/2 times 3/5 equals 3/10, then 1/3 times 4/5 equals.
Then 1/3 times what? 4/5?
Yeah.
And we're trying to figure out what it is, right?
Yeah.
Okay, let's see what happened here. First of all, when we kind of connect and see what is going on here with our problem. You with me on that? We said you've got a multiplication here, and the idea with fractions, Alyssa, is that we multiply the numerators together and we multiply the denominators. Now, you know the numerators where? In the top, and the denominators in the bottom, right? So we basically work those together. And in doing so, I'm looking at 1 times 3, and I'm getting what here? 3. You see how that connected?
Yeah.
You follow what they did? So it's kind of
Yeah.
like what they did here. They took, and I'm going to put this off to the side here a little bit. They basically said, let's do 1 times 3 in the top, and guess what? They're going to do the same thing for the denominator. We're going to say, let's do 2 times 5, all right? So basically, we're going to make this into one nice fraction, and remember what we said, 3 times 1, you know that, right? Gives us 3, correct? And what's 2 times 5 going to do for us? You there?
Yeah.
Okay, going to give us 10, right?
Yeah.
So that's what's happening there. So let's play the same game over here. Let's multiply those two numbers in the numerators together in the top, okay? Which will be what? 1 times 4? See how I'm writing that down? What's going to go on in your denominator? What are you going to do?
Multiply.
Yeah, we're going to say 3 times 5. And this time, no, we're not going to get a 10, we're not going to get a 3, but what are we going to get? 1 times 4, you know that. I know you know your multiplication facts really well. What are we going to have?
Yeah.
4, sound good? And what about 3 times 5? What's going to happen down in the denominator?
He's going to multiply it.
You got it. And what do you get when you say 3 times 5?
15.
15. And there's your final answer. That's what they're after. They wanted you to see there's a pattern, and there is. It's kind of like a rule, but they're playing with you a little bit experimentally, all right? So I'm going to put one more up here for you. Can you go with me on this?
Yeah.
What if I put 2/3 times 4/5? What's the story on this one? Now remember, you've now worked 2 like it. Same story, it's just different numbers, right?
Mm-hmm.
So what's going in the numerator? What are we going to multiply?
We're going to multiply 2 times 4.
You got it. And what are we going to multiply in our denominator?
3 times 5.
And this is why I tell our Mathline folks, why is it important to know multiplication facts? Because you can get these done and get with them pretty well. So what 2 times 4 is going to give us what, Alyssa?
8.
And how about our 3 times 5 is going to give us 15. And I'll tell you what, after you do a few problems like that, you're going to probably be able to leave out this middle step because you're going to start thinking, oh, I know 2 times 4 is 8. Go right to the answer. You see where I'm going?
Yeah.
And then 3 times 5 is 15, and life is good. It's good as long as you don't have to reduce. Now, sometimes you may have to reduce, but that's another ballgame. These 2 problems that they gave you did not require any reducing. I think they're just wanting you to see basically how to play with these fractions. Does that make sense to you?
Yeah.
All right. And that's the world of multiplication. Now, the numbers may get bigger and stuff like that, but then we can worry about, can we divide numbers like 2 or 3 into both our final answer parts and then see if they'll reduce. But at this point, you didn't have to worry about that for these 3 anyway. Okay? Does that help you a little bit?
Yeah, thank you.
All
Bye.
right. Thank you. Thank you very much. All right. Alyssa's led the way, folks. Let's get some calls going. We got Talea in Fulton High School Key Club, also accompanied by her advisor. He didn't want me to put his name out there, but Keith Leonard is here with them from Fulton High School, so we appreciate the folks from the Fulton Key Club. Now, give us a call because they want to take care of you and help you out and get you connected to me. So we've mentioned, by the way, today we've mentioned a lot of Facebook stuff going on. Let's talk about what's there, all right? Facebook, we like us, you love us, and you know, we got a lot of sharing going on, and we love more and more sharing. But like the page, like the whole thing, that's www.facebook.com with a /Mathline online. We publish the problem of the day. We give you a chance to talk about it and discuss it, and we got some good discussion. There's some great discussion going on today, and let me give some of those credits out to some of those folks. We had Sharon, Mark, Denise, and Rhonda. Also Jason, James, Anna, Vicky, all checking us out, sharing us, talking about the problem, and many of them said 16, all right? They knew where we were going. So again, take care of business. Take care of us on Facebook. We'd love to hear from you there, all right? And do I understand we have a caller waiting? Okay, welcome to Mathline. Who am I talking with this afternoon?
You are talking with Peyton, P-E-Y-T-O-N.
Peyton, how are you doing today?
I'm doing well. How about you?
You've got a famous name, you know that?
Yes, I know.
And you're famous too, I bet, right? So, hey, folks, don't get too excited. I don't think it's Peyton Manning calling here tonight, but we have a good guy named Peyton. Peyton, where are you calling from, by the way?
I'm calling from Campbell County.
Campbell County, all right, good deal. Let's hear, what kind of question have you got for me today?
All right, so a car travels 500 miles on 20 gallons of gas.
Mm-hmm.
If the rate is constant, how many miles will it travel on 14 gallons of gas?
All right, so you're telling me, first of all, we're going to be, let me just talk about this. 20 gallons gets you 500 miles, right?
Yes.
Is that right? Okay. And obviously, I think we were going to talk about the gas gallons take us there, but we can also work backwards on this. So you're wanting to know what happens if we have 14 gallons?
Yes.
What's that? I'll call it distance, all right? So what distance is going to use 14 gallons of gas for us, all right? So it kind of works both ways. We could play this either way. So what I want to do, Peyton, I want us to, you said constant rate, which is an important moment. Everybody hear that? That's a good part of the problem there, because that basically says we're going to keep traveling the same speed, the same way. We're not going to be, it's going to be an average, so to speak, all right? You follow me on that? See what I'm talking about? All right, great. So let's do proportional, because that's what we're going to do. And I like to think of it miles per gallon. So I'm going to put our 500 miles, and I'm going to put it over those 20 gallons. Okay, so far so good. You see what we did? Now, let's talk what's going on over here. Just like when I was working with Alyssa on those fractions, we want to keep the same thing going. In other words, we want miles over here, and we want gallons here also. Because this is basically, it's sort of almost like we could have reduced this maybe, but it's a strange moment because we got 14 instead of, and 20 doesn't reduce down to 14. But we've done something. And what we're going to do is we're going to put our 14 right there. And then we're going to look for, I said we'll call it D. So we'll call it D miles, okay? Don't know what it is. So the miles and the gallons are fine. Life is good. And by the way, folks, if you want to know what is the rate, what is the average rate that Peyton mentioned there, we're going at, let's do it. I think some of y'all can do it in your head, but let's see. Well, I've got some that don't want to work. Oh my goodness, now it's crazy, the zeros. Let's get rid of those. Let's clear that. We'll start again. 500, and we're going to divide by 20, I believe we said, because that's a fraction, and that means division. And that's going to tell me here we're going at 25 miles per gallon, all right? That's what that 25 is about. So I'm thinking, wow, maybe I'm going to multiply 14 times 25. We'll see in just a minute. But right now what I'm going to do, I'm going to say, well, what if I didn't know that rate was 25? Could I still solve this thing? Yes, I can. We'll cross multiply. Let me take away the words here, the miles and the gallons and stuff. So let's go with 500 over 20 equaling D over 14. Peyton, that work for you? See what we got?
Yes.
Now, let's play the cross multiply game, I like to call it. And we're going to do just that. We're going to cross multiply 500 times 14. We're going to also multiply 20 times D. And I'm catching 20D over here. Ooh, boy, what have I got? Looks like I've got 14 times 500. And I think it's going to be 7,000, but I want to make sure. 14, you all like to make sure too. I know I could feel a lot of you going, I'm going to go for the calculator on this. And I would like to too. We're at 7,000, that's good. So now we'll divide by 20. And this one does look pretty easy because 2 dividing 20 into there, that we're going to lose the zeros. And it looks like we're going to end up with half of 700, which is 350. That would be your miles, okay? Does that work for you? Now, Peyton, what did I say something about? I said something about 25, didn't I? Said maybe we could multiply 25 times 14. I'm going to go on a limb. Let's see what happens if I say 25 times 14. Is that another way to come up with the problem here? Let me clear out. And we're looking for 350 out of that. So, folks, let's try it. 25 times 14. You also could think of that as like quarters. And we'll see if it works. Quarters and cents. Yeah, 350. So there's a couple of ways you could figure that out. All right. It's all about the rate. It's all about the rate. And that rate was actually 25 miles per gallon. And when we work that into multiplying it times, hey, 14 gallons, that's what we got, 350 miles. So a couple of ways to look at it. Thank you, sir, and appreciate you calling. Tell your friends and stuff that we need to hear from them also, all right? Good problem there. Great problem. Thank you. And Campbell County. Thank you, Peyton. And folks, we got Talea here waiting for calls, all right? Let's go ahead and get some more calls in here. We got a few more minutes. 844-686-2378. That's the story we've got. That's our problem. We want to hear from you, all right? Now, yesterday, we had a problem of the day, all right? Gary Petco and I did, and we worked through it. And we said there's another option, another way to work through it. Now, yesterday, remember, we used X's and Y's. So let's take a look at this problem that I'm talking about. It was a 100-point test question containing 40 questions worth 2 and 4 points in value. So, folks, because of the too many clues, well, not too many, but there are 2 of them here, with knowing the 140-point test and you got 40 questions and you've got those values set, there's only one answer. There's only one unique answer, because let me tell you, you've got a clue that leads you to the 100 points. You've also got a clue about that the questions have to add up to 40. You've got to have a certain amount of X, certain amount of Y, or certain of the 2-point and 4-point. And you can play with this and try it until it works out. Ooh, gets kind of crazy. Now, I mentioned yesterday we could do a 1 variable. And Gary said, yeah. And we probably would have had more. We didn't have enough time yesterday because Nathaniel called us, which was great. And we had some other things that were coming up we wanted to talk about. So we let that go. But I'm going to hit back today. Let's go to, again, let's say this time we're going to let X equal number 2 pointers. But you say, now, Ernie, what are you going to do? And it's a big question. What are we going to do to represent the 4 pointers? Well, first of all, we're going to call them 4. They're worth 4. But how many do I have total? I have 40. And if I'm saying X value is going to be worth 2, the rest of them got to be 4. And they say, what do you mean the rest of them, Ernie? I mean, we're going to subtract how many we've got and do what? Subtract from what? That's the question. We're going to do 40 minus X, because that's the total questions minus the amount that we have for 2. And when we get it all done, we're going to end up with a 100-point test. That's pretty straightforward, okay? So let's do it with just 1 variable. And what we'll have to do is come back and say, well, that's X. And then we have to figure out what 40 minus X. But that shouldn't be too hard, should it? So let's distribute. Let's go with it here. We are in good shape. We are in good shape. Again, while we're doing this, give us some calls, all right? Distribute. I like that. How about it? 160 minus your 4X comes in at 100. All right. Some of you are going, oh, Ernie, we're going to have negative something. Well, just be patient. Maybe, maybe not. 2X minus 4X. There we do have a negative 2X. That was the negative something I was referring to. And we have a plus 160. Everybody's working on this at home, I hope, with me. Now, remember yesterday, what did we come up with? I think we came up with 30 and 10. That's what we're looking for, right? So we want to make sure this method works. So we had 30 here, 10 of those. Are we going to get there? Let's find out, because we're about to find out what X equals. Let's subtract 160, both sides. We like that. We've got a negative 2X. Over here, we got a negative 60. But remember, the beauty of when you divide a negative by a negative, you get a positive. And that's what we need, is a positive, and we get a 30. I believe that sounded like what we had yesterday. Now, what about this one? What is 40 minus 30? That is equal to 10. Now, keep in mind, you say, wait a minute, Ernie, what did you do? I said 40 minus X. That equals our 4 pointers, okay? And that's the number of. This one was the number of 2-point questions. So even though we had 2 clues, and yes, we could have used 2 variables of X and Y, we could also condense it down into 1 variable. That's pretty cool. Again, an optional way of looking at it. So we had 30 2-point questions. We had 10 4-point questions. And you can figure that one out real easy. Check it. Everybody loves to check it, right? So we've got what? 30 times 2 makes 60 points. 10 times 4 gives you 40. Good test. Good test. Good test question. All sorts of good things. So again, another look at yesterday's problem of the day. Hey, folks, we have been glad to have it. I want to say once again a nice shout out, a thank you to Leah. Appreciate you from Fulton High School. Key Club, let's wave out there, get one last look at her. Yes, thank you for being with us today. And Keith Leonard joining her. Also, I think they're going to be back next Tuesday, so we want to look forward to having them back in the studio. And again, we love it when they get calls from you guys out there. We thank you for tuning in today. We so much appreciate it. And school year is getting into swing. Go ahead and get our number if you haven't. Put it in your speed dial. Put it in your phone, 844-686-2378. We love it when you talk to us on Facebook. We love it when you deal with us on YouTube. But we really, really love it on these days that we're live, that you give us some calls and we get to work math problems live on the air. Gary Petco and I both love it, and I love it when you guys call in. Thank you so much for tuning in today. And as I always tell you, we hope and we will see you next time.